the last section that we're going to cover in this class. Matrix inversion. So before we get to matrix inversion, we're going to talk a little bit about arithmetic. Right? It's always good to relate what we can do with matrices with what we can do with numbers, because we learn numbers first. And so the first question in my arithmetic review is, what do we call a pair of numbers that multiply together to give us 1? Right, well, I'll give you an example and maybe you can come up with a name. So if I take 5/4 and multiply it by 4/5, that gives me 20 over 20, which reduces to 1. Or 1/2 times 2, same thing, gives me out 1. And so what are those numbers called when we flip the numerator and the denominator? It's basically what we did in these. Well, those special names, they're called reciprocals. Numbers. And the important property about a reciprocal number is when we multiply them, we get 1 out. Right? We usually say flip the numerator and denominator. And so we get the following property of real number values. Whenever I have, as long as it's not 0, right? 0 does not have a reciprocal, because can't divide by 0. But every number but 0 has a reciprocal. All real number values. So if I have a, multiply it by 1 over a, it's reciprocal, or 1 over a times a, I'll always get 1 out. And that's the identity property called the reciprocals, or more formally multiplicative inverses. Another way we can write an inverse is a to the negative 1. 1 over a, using exponential notation, is the same as a to the negative first. And I get the same thing. You can test it out on your calculator. Take 2 times 2 to the negative first. 2 to the negative first times 2. It gives you 1 out, because 2 to the negative first is 1/2. Right? If you take 2 and raise it to the negative 1 power, you get 1/2 out. And so again, these are reciprocals, or more formally, they're known as multiplicative inverses. They undo one another. When I take 2 and multiply it by 1/2, it undoes the 2 and leaves me with 1. Where we use this in algebra is to help us solve equations. All right. So, for example, I've got my 2x equals 16. I want to solve for x. Well, I need to get rid of the 2. I want a 1x there. Well, I can get rid of the 2 by multiplying by 1/2. Well, whatever I do to one side of the equation, I have to do to the other side. And so again, those are reciprocals. They undo one another. They undo multiplying. The 1/2 undoes the multiplying by 2. Leaves me with just the x. On the other side, well, again, in order to you keep equality, whatever I do to one side of an equation, I have to do the other. So 16 times 1/2 is going to leave me with 8. And that's true. If I plug that back in, that's true. 2 times 8 does give me out 16. The second example, again, same idea. I have to solve for x. I need to get rid of the 2/3. Well, to get rid of the 2/3, I multiply by its reciprocal, 3/2. Well, whatever I do to one side of the equation, I have to do to the other side. Again, the reciprocals cancel each other out. Undo one another. That's why they're called inverses. They reduce to 1, right? And that leaves me with just x on that side. And then whatever I do to one side, I have to do the other. So since I multiplied by 3/2 on one side, I have to multiply by 3/2. And so that reduces to 5 times 3, which is 15. And if you check it out, you take 2/3 times 15, you will be left with 10. Right? And so that's how we use inverses, reciprocals, multiplicative inverses, with numbers, right, in arithmetic and algebra. Right? So how can we relate that to matrices, right? We're dealing with matrices right now. Well, this is the very last thing I talked about in 4.2. That's why I said in 4.2, when we talked about this, it's actually going to be used more now than it is in our 4.2. What matrix can we multiply by another matrix to get our original matrix back? Well, that was the identity matrix, right? The I sub n, the identity. So remember, it was I sub 2 was 0, 1, 0, 1, 2, or I sub 3. And we typically stick with 2x2s and 3x3s, but it would be I sub 4, and I did an example in the last video. And so remember, as long as the math works, I have matrix A times some identity matrix, as long as the math is defined, I could take that identity matrix and get A back out. So the identity matrix is the one of matrices. So that's the 1. So remember, kind of 1 is our goal here. If you go back and look at the arithmetic, the goal was to get 1 out. Right? When I multiplied my two numbers, I got 1 out. And so the goal is going to be, is we're going to want to find the identity matrix. We want to find some matrix A times some matrix B, which will give me my identity matrix. That's what we're leading up to here in this section. Right? That's what we're going to want to find. I want to find, how can I multiply two matrices together to get my identity matrix to come out? All right, and that's what we're going to get into in the next section. All right, so we'll get into that in the next set of videos.